The today's topic is data link protocols for the noisy and noiseless channels. Channels means your transmission media. Now we are having a number of protocols, and that protocols come under the category of the data link layer. The protocols that are used in data link layer for the noisy as well as the noiseless channel. Noisy means where the noise is there, or the noiseless means where the less amount of noise is there. So let's start with this topic. Data link protocol for noisy and noiseless channels. Data link protocols can be broadly divided into the two categories depending on whether the transmission channel is noiseless or noisy. We can bifurcate the number of protocols accordingly to the state of the channel. The state of the channel means either the channel is noiseless, means the no noise is there. Noise means some external noise. And the second one is the noisy. Noisy means when some noise is present in between that particular channel or over the transmission media. So let's start with the number of protocols. The first protocol is stop and wait ARQ. ARQ represents automatic repeat request. What is the first protocol is stop and wait ARQ. How it works? Let's start with this. At first, sender A sends a data frame or a packet with the sequence number 0. After that, receiver B, after receiving the data frame, sends an acknowledgement with the sequence number 1. Sequence number of the next expected data frame or the packet. What it means, that sequence number is directly depends upon the next packet that a sender wants to send. There is only one bit sequence number that implies that both sender and receiver have buffer for one frame or a packet only. What it means, this bit sequence number simply implies that both the sender as well as the receiver, they have the buffer space for a single packet or a single frame only. What it means, suppose I am the sender, you are the receiver. I just send the frame number 0 towards you. Whenever you receive that frame, you send the acknowledgement with some reference number, or you send the acknowledgement with the sequence number 1. So what it means, that I come to know the 0 frame or the 0 packet is received by your side. Now you are looking for the next packet. Clear? So this is the diagram. With the help of this diagram, everything is clear. Now look at clearly on your screens. The A is there. A is the sender. B is there. B is the receiver. Now A sends the frame 0. That is right here. Frame 0. Now the frame is received by the B. When a frame is received by the B sends the acknowledgement for the frame number 0. And he sent the acknowledgement with a sequence number 1. ACK represents the acknowledgement. So he sends the ACK1 towards to the sender. Whenever a sender receives the acknowledgement 1, now the sender comes to know that frame 0 is received by the receiver side. So it sends the next frame. Suppose the next frame name is the frame number 1. It sends the frame number 1. And again, receiver receives the frame number 1 and sends the acknowledgement number 0. ACK 0. Whenever a sender received the ACK 0, what it means, it received the previous frame. Now the receiver looks from the next frame. Now at the next time, A sends the frame number 0. Now look at it, the cross is there. Cross means due to some interruption, that particular frame number 0 is not received by the receiver. Look at here, the frame number 0 is not received. Now we have the timeout. Timeout means the name of this protocol is automatic repeat request. What it means, we have a timeout. For example, we have a 30-second time. If the acknowledgement is not received, so we are automatically understand that our packet or the frame is not received by the receiver. That's why no acknowledgement is coming from that side. So after that time, for example, if the time is 30 seconds, so after passing the 30 second, that is, this is the timeout, then again we can send the same frame. again we are sending the frame number 0. Now the frame number 0 is received by the receiver. It sends the ACK1. ACK1 means the acknowledgement number 1. So what will happen? The frame 0 is received. This is the first problem from the sender side, if the frame is not sent by the sender side. Now the second problem is also there. Now look at here. We are at the sender side. We send the frame number 1. Frame 1 is received by the receiver. Now it sends the receiver sends the acknowledgement number 0. But the acknowledgement 0 is not received by us. It is lost due to some interruption. So if a no not acknowledgement is received by our side, what we are assuming? We are assuming that our frame is not received. Either the problem is in the frame receiving option or the acknowledgement received option. So again, the timeout window is there. Whenever the timeout window is completed, again it resend the frame number 1. Then again the frame 1 is received by the receiver. But what will happen? Look at here. We discarded the duplicate frame because in the previous step the frame is received by the B, but the acknowledgement is lost. Again, whenever a receiver receives the frame, it again sends the acknowledgement. Whenever it sends the acknowledgement, then the acknowledgement is received by the sender. Then he comes to know that now my frame number 1 is received by the receiver. The next protocol is sliding window protocol. The sliding window is a technique for sending multiple frames at a time. It controls the data packets between the two devices where reliable and gradual delivery of the data frame is needed. It is also used in TCP. So basically, sliding window protocol is used to send the multiple frames. Whenever we have the multiple frames to send the simultaneously, we use the sliding window protocol. And normally it is used under the category of TCP, or also used in TCP, that is transmission control protocol. In this technique, each frame has sent from the sequence number. The sequence numbers are used to find the missing data in the received end. The purpose of the sliding window technique is to avoid the duplicate data, so it uses the sequence number. Now the concept that is used in the sliding window protocol is a sequence number, because we know the multiple frames can be sent at the same time from sender to receiver. Suppose I am a sender, you are a receiver. When I am trying to send a multiple frames towards your side, I just give the sequence number to each and every frame. Suppose I want to send the 10 frames. I give them the sequence number like 1, 2, 3, 4, so on to the 10. So it's with the help of sequence number, it's easy to find out which particular frame is not received by the receiver. So this is all about the sliding window protocol. Now we have the types of sliding window protocol. The sliding window protocol has the two types. Now it furtherly categorized into the two categories. The first is go back and ARQ, and second is selective repeat ARQ. Now let's start with the first one, working of go back and ARQ. Suppose there are a sender and a receiver, and let's assume that there are 11 frames to be sent. Suppose we are going to send the 11 frames, and just compare it with the example. I am a sender, you are a receiver, and I want to send the 11 frames. So I represent all the frames with the sequence number. First thing is I just give the sequence number to every frame. Now I give the sequence number from 0 to 10. I have total 11 frames. I just give the sequence number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these are the sequence numbers of the frames. Mainly the sequence number is decided by the sender's window size. Basically, sequence number depends upon the sender's window size. Window size means now we have a window of, suppose a window is either is of size of 1, 2, 3, 4, 5, 6, 7, 8 of any size. Suppose if a window size is 11, then I am able to deal with the 11 frames at the same time. Clear? Or if the window size is suppose 11, and in the second option, suppose the window size is 3. So what it means, at the same time the 3 frames can be sent. Let's consider the window size as 4, which means that the 4 frames can be sent at a time before expecting the acknowledgement of the first frame. Now what will happen? Let's start with understanding this example. Step one, first you look at here. Firstly, the sender will send the first 4 frames to the receiver, that is 0, 1, 2, 3. And now the sender is expected to receive the acknowledgement of 0th frame. What will happen? Now look at the diagram. It will clear smoothly. Working of go back NRQ. This is the complete window. Window is 0, 1, 2, 3, 4, 5, so on to 10. These are the sequence numbers. Now this is a sliding window. Sliding window means the window whose slides either towards to a right side, either towards to a left side. Clear? Now the window size here, the window size is 4. Now look at the yellow diagram is there. 0, 1, 2, 3. This is a sliding window, so the window size is 4. So what will happen at the same time? This is a center side. Now sender sends the 4 frames. Look at the second diagram. It is a sender. It sends the 0 frame, first frame, second frame, and third frame. This is a receiver. This is step number 1. Clear? Now let's assume that the receiver has sent the acknowledgement for the 0 frame and receiver has successfully received it. So what will happen? The first diagram remains the same. Here, sliding window is of 4 size. The window size is 4. Now look at this diagram. Receiver sends the acknowledgement of 0 frame. What will happen? The acknowledgement of 0 frame is received by the sender. Now, if I am the sender, I come to know that frame number 0 is received by your side. What will happen next? Now, the sender will then send the next frame, that is 4, and the window slides containing the 4 frames. Now, this is the main point. Now, look at here. It is a sender side window. I am a sender. I received the acknowledgement of 0. So automatically the window is slides to the left side. Why? Because 0 acknowledgement is received. Now 0 is out of the window. 0 is received. I am not going to send the 0. Now the window size remains the same. But what is the value of window right now? If the 0 is out of the window, now the next is the 4. 4 comes into the window. Now the window have 1, 2, 3, 4. Clear? Now look at the second diagram. Whenever a receiver sends the frame number 0's acknowledgement, whenever an acknowledgement of 0 is received, look at your screens. The 4 number frame is already sent at that side. Why sent? Because the window size remains the same. The size of the window is 4. What it means, at the same time, total 4 frames can be contained by the window. Now this will happen. 0 is out of the window and 4 comes towards to the window. Suppose at the next step, the acknowledgement of the 1 is received. So automatically window moves to left side, one more step. So 5 comes into the window and 1 is out of the window. Clear? Now look at here. The receiver will then send the acknowledgement for the frame number 1. After receiving the acknowledgement, the sender will send the next frame, that is frame number 5. And the windows will slide having the 4 frames, that is 2, 3, 4, 5. Now what will happen? Look at the second figure. Look at here. Frame number 1 is sent. Whenever a frame number 1 is received, the 5 is right over there. Why the 5 is right over there? At the same time, it sends the 5th frame. That sequence number is 5 because it received the acknowledgement of first frame. Now whenever the frame number 1 is received, frame 1 is automatically comes out of the window. Window size is 4. Now the total number of frames that reside in the window remains the 3. So automatically 5 comes into the window, as shown in the diagram. Clear? So at the next step, now let's assume that the receiver is not acknowledging the frame number 2. Either the frame is lost or the acknowledgement is lost. Now either we have the 2 options. Either the frame is lost, or if the frame is received by the receiver, or then the acknowledgement is lost. Instead of sending the frame number 6, the sender go back to the 2, which is the first frame of the current window, retransmit all the frames in the current window, that is 2, 3, 4, 5. Now look at the diagram carefully. If a frame is lost or if acknowledgement is lost, what will happen? Now look at the diagram. The window size remains the same, 2, 3, 4, 5. Now look at here. It sends the frame number. It sends the frame number 5. When the frame number 5 is received, they send the frame number 1. Acknowledgement of frame is received. They send the frame number 5. Now next it receives the frame number 2. It sends the acknowledgement for the frame number 2, but that acknowledgement is not received by the sender. Whenever I am a sender, whenever I am not able to receive any further acknowledgement, I am not going to move the window to the left side. Whenever I received acknowledgement of the next frame, only in only that condition, I move or I slide the window towards to the left side. What will happen here? The window remains the same. Why? Because the acknowledgement is not received by the sender. Clear? So the next, how it works. Now the 2, 3, 4, 5. Now look at here. Go back to 2. Again, it go back to the 2, sequence number 2. Again, look at here. Again, it sends the frame number 2, frame number 3, frame number 4, frame number 5. Now, what will happen at the next step? Again, it sends the acknowledgement of 2, the receiver. Then the window moves to the 6th point. Look at here your diagram. Whenever it received the frame number acknowledgement for the frame number 3, the window moves to the 7th point. Sequence number 7 comes into the as step by step. When all the frames are received by the receiver, whenever it sends the acknowledgement of the next frame, next frame, next frame, the window moves to the left side. As the window moves to the left side, at the end, the window size at the last point, whenever the window is at the 7, 8, 9, 10, then it shrinks the window. 7 now goes to the 8, goes to the 9, goes to the 10. Then all the sequence numbers of the frame, they are out of the window. What will happen if all the sequence numbers are out of the window? This will come to know that all the data that sender wants to send is sent towards to the receiver side, and all the acknowledgements for the particular sequence number can be received by the sender. So this is go back and ARQ protocol. The next is important points related to go back and ARQ. These are the four different the important points related with this protocol, and the name of the protocol is go back and automatic repeat request. The first is in go back, and n determines the sender's window size, and the size of the receiver window is always 1. Yes, the n decides the size window size of sender. Suppose I am a sender, it depends upon me. If I have the window size of 4, n represents the 4, and the size of the receiver window is always 1. Why always 1? Because it receives the frames one by one. Whenever it receives the first frame, it sends the acknowledgement. Then the next frame will come, it sends the acknowledgement. Then the next frame is come, it sends the acknowledgement. Clear? It does not consider the corrupted frames and simply discard them. If the frames are corrupted, it doesn't consider that frames and discard that frames. If the frames are discarded by the receiver, so the no acknowledgement is sent towards to the sender side. If the no acknowledgement is received by the sender, it automatically go back to the particular point and sends the all the frames. Third, it does not accept the frames which are out of order and discard them. The out of order frames cannot be received. Suppose you are the receiver, that's why the sequence number is there. I just add the sequence number. I just add the 1, 2, 3. First, you have to receive 1, then you receive the second frame. If you see the 4th frame after the second, you simply discard that particular frame because you are looking for the frame number 3. That's why we are giving the sequence number onto the every frame. 4th, if the sender does not receive the acknowledgement, it leads to the transmission of all the current window frames that we shown in the previous diagrams. If the sender does not receive the acknowledgement, suppose I am a sender, if I am not received the particular acknowledgement, I retransmit all the frames that are the part of that current window. The number of frames that are the part of that current window, all the frames can be resent towards to the receiver side. Clear? The next protocol is selective repeat ARQ. In selective repeat ARQ is also known as the selective repeat automatic repeat request. It is a data link layer protocol that uses a sliding window method. The go back and ARQ protocol works well if it has fewer errors. But if there is a lot of error in the frame, lots of bandwidth loss in sending the frame again. So we use the selective repeat ARQ protocol. In this protocol, the size of the center window is always equal to the size of the receiver's window. The size of the sliding window is always greater than 1. Now, what is the difference between the previous one and the next protocol, that is selective repeat? The main difference is, in the case of go back and ARQ, if the acknowledgement is not received, it retransmit all the packets that are the part of that front window. So what will happen? It is a time consuming process, and the go back and ARQ protocol only works when a few error is there. If the error is more, then it can't be worked smoothly. Why? Because if the error is more, it simply discard the frame. Whenever the frames are discarded, again it retransmit all the frames. So it is a time consuming process. To overcome this problem, we have a new protocol, and that protocol name is selective repeat ARQ. Clear? If the receiver receives a corrupt frame, it does not directly discard. But what will happen in the case of go back ARQ? If receiver receives a corrupt frame, it simply discard. But that will not happen in the selective repeat ARQ. It not discard that instantly. It waits for some time, check the value of that frame, then take the decisions. It sends a negative acknowledgement to the sender. Now, the main concept is it sends the negative acknowledgement for the error consuming frames. For these, it sends the negative acknowledgement. The sender sends that frame again as soon as on the receiving negative acknowledgement. Whenever, so I am a sender, whenever I receive a negative acknowledgement, I again resend that particular frame. So there is no waiting for any timeout to send that frame. Now, how we can save the time? Because there is no timeout time is there. In the previous one, we have a 30-second timeout is there. If we cannot receive the acknowledgement for the 30 seconds, then we again resend that particular frame. So what it means, we have to wait for 30 seconds. But what will happen in this case, if the receiver receives a corrupted frame, at the same time it sends a negative acknowledgement. If the negative acknowledgement is received by the particular frame, the sender, it again retransmit all the packets. So this is all about the selective repeat ARQ. Now look at the diagram, the example of the selective repeat ARQ. First thing that is very clear, the window size is same. In this case, in the sender side or the receiver side. Look at here, at the center is 0, 1, 2, 3, 0, 1, 2. At the receiver side, 0, 1, 2, 3, 0, 1, 2. Frame 0 is sent. Currently, the 2 frames at the window size, but sender is at the 0 frame. Look at the S is there. Now the 0 frame is sent, then the frame number 1 is sent. It sends the 2 frames. Two frames are the part of the window. Whenever at the receiver side, look at here, it receives the 2 frames, it sends the acknowledgement 2. What it means, now he's expecting the frame number 2. So both the frames, they comes out of the window, and next 2 frames comes into the window. 2 and 3 is there. Now it sends the frame number 2. The frame 2 is lost. It sends the frame number 3. It receives the frame number 3. It receives the frame number 3, but it sends the negative NAK. That is called the negative acknowledgement of the frame number 2. Now, whenever it receives the negative acknowledgement of frame number 2, it again resend the frame number 2. This is the concept of selective repeat ARQ. What will happen? It only send the selective frame. If the same can be happen in the case of selective go back and ARQ, whenever a frame is lost, it again resend the frame number 2 and the frame number 3. But in this case, it only sends the negative acknowledgement of frame number 2, but not send any acknowledgement for the frame number 3. Clear? So this is all about the selective repeat ARQ. Okay, now the difference between the go back and ARQ and the selective repeat ARQ. In the case of go back, if a frame is corrupted or lost in it, all the subsequent frames have to be sent again. Yes, we all know. But in the case of selective repeat, the frame is sent again, which is corrupted or lost. Only that particular frame is sent that is corrupted or lost. Next, if it has a higher error rate, it wastes a lot of bandwidth, but that can't be happen in the case of selective repeat. there is loss of bandwidth, there is a loss of low bandwidth is there, because we cannot resend all the frames. Now what, and third is it is less complex. Selective वाले केस में it is more complex because it has to do sorting and searching as well, and it is also requires more storage. Why the sorting and searching? Because it can receive all the frames either they are in the sequence order or not in the sequence order. Clear? Fourth, it does not require sorting. It does not require sorting. Why? Because the method is it only receives the frames that are in the sequence order 1, 2, 3, 4. That's why no sorting is there. But in the case of selective repeat, in this case, sorting is done to get the frames in the correct order, because it can receive the frames in any order. Suppose the 5 frames are sent, it receives the frame 1, 2, 5, 3, 4. But at the end, when all the frames are received, it sort the frames to make a particular order. Next, it does not require searching in the case of go back, but the search option is performed in it, because with the help of search option, they come to know the number of frames are received, and then the sorting is applied. The last is it is used more. Go back is used more. Why more? Because it is less complex. Look at the third point. It is less complex, so that's why it is used more. It is used less because it is more complex. It is used less because it is more complex in the case of selective repeat. Why the selective repeat is more complex? Because it can receive all the packets either in any order, it can sort all the packets, it can search for all the packets. That's why this process is complex and is less used by the users. So this is all about the protocols, and at the end, the difference between the go back and ARQ and selective repeat ARQ.